So, I'll let you do the switching of the slides. So, again, me, and again, I'm standing between you and this time the finishing event, not the first break. The good thing is that Nino said I can take as much time as I want, so strap in, we'll have a fun session ahead. No worries, we'll stick to the 20-25 minutes we originally had. After this morning's session, where I talked a lot about processes, about the change that Dynatrace as an organization underwent, I now also want to spend a little bit time of what are we actually building? Because some of you have asked me in one of the breaks, so it's great that we now know how you transformed into a DevOps culture, but what is it actually you guys do? Well, Dynatrace is a provider of monitoring software. And I want to walk you briefly through what's the rationale, what's the idea behind the monitoring approach that Dynatrace has taken. And fundamentally, the first part for monitoring, if I click into the right direction, is that a lot of the organizations that we work with worldwide, they go through a digital transformation. A digital transformation that has hit literally every vertical. There is no part where, yeah, it's something that banks think of, but that it doesn't apply for that. It hits everything. Just think of the way you travel, the way you do business in, be it banks, insurances, the way you work with your government, when you can do things online, e-government initiatives. And this digital transformation, there's a lot more quotes than I can put on a single slide of organizations, how profoundly it has changed the way they do business. And let's not kid ourselves, the digital transformation is not easy. The digital transformation changes some of the very fundamental things, and one very important aspect is what we talked about earlier today about with DevOps. It fundamentally changed how we develop software, how we approach things, how we get from idea to working product and all the steps in between. But it, of course, also impacts how you architect applications more technically, microservices, containers, cloud platforms. And with cloud, don't just think about public cloud. Private clouds, be it Red Hat with their OpenShift platform, be it Pivotal with their Cloud Foundry-based platform, are pushing strongly into a completely different way of how you build applications. And in a world like this, classical monitoring is simply no longer enough. If you have your classic monitoring of dashboards, you have war rooms when something happens, and God knows I've been part of way too many war rooms over the years where you had teams and teams, everyone had their tools, and when you asked around, so where's the problem? Everyone raised their hand and said, it's not in my part, everything's green for me. That's not very productive. And what's also not very productive is that in a war room, you typically have your best people. That's where you have your not only highest paid, but your most productive people that would much rather contribute to your business rather than trying to fix stuff or trying to figure out where problems come from. So why do I think traditional monitoring, alert-based monitoring, is no longer enough? Well, one aspect, applications, over the years got more and more complex. Just a simple example. Every one of you has a mobile phone, and most of you probably have an app from your bank where you can check, what's my current balance on my checking account? Now just think through how many different technologies that simple touch on your mobile app will actually cause. It will touch probably something that's running in the cloud or something that offloads the initial requests. It will go through web servers, application servers. There will be maybe a CDN for the app somewhere involved, middleware, network connectivity, backend systems, maybe a mainframe somewhere at the end. The number 82 is not one that I've just made up because I felt like 82 sounds so much better than just saying 80. We literally spent about a week with one of our customers to just count a very similar transaction. It wasn't exactly a banking application, but mobile to backend system. And just how many different technologies did we touch along that way? And 82 was the real number that we came up in that exercise. Not only is it more technologies, it's also the application itself, the code behind our application that gets more and more complex. The example that I used here is one from a US-based car company. I've just last week spent almost an afternoon with a large German car company, BMW. If you ask them how their software development has changed over the last 10 years, they'll probably tell you 10 years ago, we had a couple of developers that focused mostly on embedded stuff. Embedded stuff as in, of course, you need some level of automation inside the car. Since then, they have hundreds of people just working on the back-end services for their connected car. For the little head unit that you have in your car that shows you everything from live traffic to your favorite Spotify music to making service appointments straight through the applications there. The reason why that has changed so much, because that's how they differentiate. If you ask a BMW, if you ask Volkswagen, how they differentiate, well, they differentiate based on software. Not based on car, not based on colors, not based on engines, whether they meet standards when it comes to pollution or not through the car itself, but mostly through the software that runs in there. And as said, the number is from Ford. BMW, very German company, without saying the exact stats, said, yeah, you know what, that sounds about right where we are. And it continues growing into that area. Changing environments. Gone are the days where you put in a server and then you had literally a couple of weeks, sometimes years, of that server doing exactly the same thing for a prolonged period. Nowadays, I have many customers where the production environment changes on an hourly basis. Containers, orchestration decides to move services from here to there, spin up more, take down services. Now imagine, as somebody responsible for monitoring that system, do you think you'd keep up with an orchestration engine that constantly changes something, and then you get an error that says there's only 5 services running? Is that good? Bad? Normal? Should it be 5? Should it be 3? Should it be 10? Difficult to know if you don't have a monitoring solution that helps you with that aspect of not just the application, but also the environment where it's running in. And the last piece is something that over the last probably 2 years I start to see more and more often. Often enough that the English language now even has an official word for the social media phenomena that happens when applications go wrong. Shitstorms. We all know them. Something relatively small goes wrong and suddenly you have this huge eruption in social media about how this application's complete crap and how it's never worked. We all know the old saying that it takes 1 bad customer to equalize about 10 good customers. 10 customers saying good things about you are completely outdone by 1 very vocal guy complaining about your application. And those shitstorms, they're unfair. Yes, they are absolutely unfair. Every one of you is compared against an Amazon, against a Facebook, against a Google, and the way they deliver software and the level of performance that they can deliver. Is it fair to be compared against an Amazon which has multi-data centers across the globe, has a lot more development power? No, it's not fair, but guess what? Users are not always fair in the way they treat us with their applications. So what can we do? What can we do to make sure that our monitoring teams are not completely left out there, fighting with tools not equipped, not built for those type of landscapes? How can we do to make sure that organizations don't become digital prey? They don't become one of those long list of organizations, be it Blockbuster in the US, which completely went out of business based on a business model that they simply couldn't afford anymore, or the long list of companies that Amazon has put out of business simply based on being consistently focused on user experience. Well, the good news, it's not all doom and gloom. There's a good side of that story, so don't worry. We're getting into there is a solution for this part of the story now, is that machines have started to learn tremendously. Over the last probably 4, even 5 years, machine learning leaps and bounds compared to what it was. How often have you mistyped, sometimes really badly in Google when looking for something, yet Google figured out what you actually wanted to search for and even said, you know what, rather than correct you, I'm just going to show you the results, tell me if I was wrong. And in my opinion, they're very rarely are they wrong with what they autocomplete me for. Or situations like fraud detection. In my job, I travel a lot, which means I encounter fraud detection more often than not. I'm actually surprised that my credit card, yes, this morning here actually worked, because normally when I enter a country for the first time, somebody at Bank of America then realizes he's never been there, so probably his card has been stolen. No, it has not. But still, there's machine learning behind it. I now get a short text message where I reply to, yes, this is really me, it's all good, and the transaction went through. No longer do I need to call somebody, call center. Machine learning's impacted a lot of parts of our infrastructure. And what we at Dynatrace now started to do is to apply the same level of automation, of machine learning, also to monitoring. Why do I need to manually tell my monitoring solution which processes are important? Why do we need to manually tell it how things are interlinked? Those are things that machines are really good at figuring out on their own. Processes that don't communicate on the network, don't get a lot of requests because there's nothing inbound, well, normally they're not that important. On the other hand, if you have processes that get a lot of incoming network traffic, well, if that process is gone, obviously something will be impacted by a change like this. Automation that also includes things like upgrades. Why do I need to do upgrades manually? Especially, as we've talked about earlier, especially if you're doing them every 2 weeks. Who wants to upgrade their monitoring solution every 2 weeks? Nobody wants to do that manually. So it needs to happen in the background, and it needs to happen automatically for you. So what Dynatrace now tries to build, and later on we'll have probably at least a minute or two to actually show you the product as well, is first of all, combine data from as many sources as we possibly can. So we have an agent that collects a lot of data about the infrastructure, applications, processes, goes down to source code level on Java and .NET languages. We have a JavaScript agent that includes real user monitoring data, synthetic monitoring data, so robots running transactions, so you can be sure that if nobody's on your side, it's not because you're down to the outside, but because it's simply that at 2 a.m. nobody needed your service. It includes things like log files. It includes things like mobile monitoring, but also platforms you run on, OpenShift metrics, or AWS, Azure Cloud, Google's cloud platform, whatever infrastructure you provider you decided underneath. And with all those metrics, we then, wrong direction, we then start putting them together into a model that you can almost visualize like a live CMDB of your production system. One that is always accurate. Even if you change in a minute-by-minute basis, this picture will always show you what's running where and where are dependencies in your environment. This model is where the AI will then do its job on. So this model is where the machine learning will then start learning what's normal, what's abnormal, and start producing not just more data, not just alerts that a human then again has to correlate and look at, but really then provide actionable insight, because this actionable insight is one of the key ingredients to the automation that I talked about earlier this morning, to going towards an autonomous cloud, to going towards a system that is self-healing and that can do things automatically on its own. So rather than showing you more slides about what Dynatrace can do, I'm now going to try to switch over and let's see if I can actually get a live demo to work here so that you can actually see how Dynatrace really works for you. And yes, this is completely untested, so it will be fun for all of us if this works or if it doesn't work. So I'm connecting to our SaaS platform where I have a demo environment that I can actually look at and try to show you how Dynatrace works. And I'm really happy that this keyboard actually looks like a US keyboard, because else I would be really struggling right now. Woo! Yes, password, first try. So, Dynatrace. So what you'll see is the main console that you interact with Dynatrace. So Dynatrace is a fully web-based application. There's no client to install. It is just run as a web UI. And of course, you see here, there is a dashboard that visualizes the current state of my system. So yes, how many applications do I monitor, databases, hosts, user health, and so on. And typically, I start those demos with, well, how do we generate data? But to be quite honest, it's A, quite late in the day, B, we are short on time, so I'm going to skip the install of an agent because that's boring. That's something you do a single time, and this agent install, literally, there's nothing else than run the installer, done. Everything else is done automatically. So we're going to jump straight ahead into what happens with all the data that Dynatrace generates. And I mentioned before, we build up a model, an interactive CMDB-like model that shows you, in this case, how services are interlinked. But if we start from the bottom, it also shows me the physical servers, hosts, that I use within my system. And for each of them, it shows me which processes are running on this specific host. For each process, which services does it provide? Remember, in today's service-based architectures, microservices, a single process might serve just one service, or the reality is most people are not far enough in the microservices chain yet, so that's one process has multiple functionalities. It provides maybe the authentication, but also the authorization service within one process. So in this case, we see this one process here, down here, it's an Apache HTTP. It provides 3 different services, which means it actually responds to 3 different ports that are in turn used then by 3 different applications. EasyTravel.com is the demo application I run here in multiple facets. Now, Dynatrace does not only provide you this high-level model, which is architecturally definitely interesting and helps you understand how your application really works in production, but it also provides a lot of data behind each of those data points. So if I start at the host level, this is where we are now in the classical infrastructure monitoring area. CPU, memory, disk utilizations, network connectivities, quality metrics, retransmission rates. So we are literally at the operating system at the host level. Of course, we include availability because, yes, if the basic server is not even available, all the other layers are kind of pointless. If the server is not running, I can guarantee your application will be down. But then we can also dive into the individual processes to say, okay, there's a Java process. Let's dig deeper. Well, let's dig deeper. In this case means CPU, how quickly does it respond, how much memory does it take, or if we take another example, let's see what else is running on this one. Let's pick our HTTP server that we had earlier. How many requests does it have? How much network traffic does this specific process get? So we're switching from pure infrastructure monitoring now towards application-focused monitoring. I can also, from within here, directly see the log files. So Dynatrace includes log files, again, automatically. Nobody's ever told the Dynatrace agent that this is a log file and that this should be monitored. The agent picks that up automatically. And the cool thing is, not only do I have a lot of data, but behind each of those metrics that you see here, Dynatrace learns what is normal and what is abnormal behavior. This process, well, very clearly normally produces around 10% CPU utilization. If this process suddenly produces 50%, that's an anomaly. An anomaly that normally you would now alert on. Somebody would get an alert that says this process takes 5 times as much CPU, and then we're back to a human looking at the process, trying to understand what's going on, how many requests does it have, is it the only process, is it 1 out of 10 processes that has that problem? Now remember what I said before, Dynatrace has a model. Dynatrace knows what's going on, and we know how many requests this process gets, who it is depending on, maybe which database it is relying on. So we can start to link all those individual anomalies, all these individual alerts together into something we then call problems. And that's the last part I want to show you for today's demo here is, very briefly, how such a correlated problem then actually looks like. So where's an interesting problem that I can use for actually showing you something? Let's use this one. A problem that happened earlier, it happened actually between 4 a.m. and 4:28, so this problem occurred for around 27 minutes this morning. The system straight up tells me this problem affected real users. So it's not one of those problems where you can argue, well, did somebody notice at 4 a.m. in the morning? Yes, actual end customers noticed that there is a problem. We can see here What is the problem, or how many users? Okay, 61 individual users had been impacted with around 700 service calls. The system also tells me the application that was impacted, it was impacted by JavaScript failures. So something happened on the browser that the user could no longer get to the application. It happened across all locations, all operating systems, all browsers, so it's not a problem that happened just in China or just in Europe, but it happened all over the place. And the system then also straight up tells me, what's the root cause? Well, the root cause is one of my processes crashed. But before we jump into the root cause, let's take a look at how Dynatrace has correlated and linked individual alerts and anomalies. So when this problem started, we started seeing anomalies. We started more and more anomalies, and about 5 minutes after this problem started, we had 38 individual anomalies. 38 alerts that would have spammed your operations team at 4 a.m. in the morning, where you hope that somebody is awake enough and knows the infrastructure well enough to say, yeah, don't worry, those are all problems because one database went down. Ignore the other 37. They're all just the result. They're not the root cause of this problem here. And now picture what would have happened in your environments if 2 problems would have hit at 4 a.m. in the morning. If it wouldn't be 38 alerts, if it would have been 80 alerts. Would your operation team have sorted them out and say, yeah, those 38 belong to this problem and those other 50 need to be handled separately because we just happen to have 2 problems occurring at the same time? I can guarantee you, in a small environment like this, yes, maybe a human has that capacity. If you're talking about hundreds or thousands of servers, you are beyond what a human can really do efficiently without, again, getting into war rooms, getting a lot of humans together, and then hopefully drawing the right conclusions. Machine learning can keep up with this data. The system that I've shown you here is currently deployed in environments that are around 15 to 20,000 hosts in size. That's what SAP, for example, uses for their cloud platform to monitor their own instances and how they are linked with each other. And of course, when something happens, I see the root cause from within here, and I can dive straight into the details. Straight into the details meaning I see that this process is actually crashing once a day. Yes, it's a demo platform, so of course there is problems happening regularly. You see that this process crashed, and a couple of minutes later it was actually restarted. Interestingly enough, the crash to restart was about 5 minutes, but our problem for the end users, it took about 30 minutes until all systems went back to normal. And from within here, as an operator, I can even start straight up to look into the log file to maybe better understand why this process crashed. Is there maybe something that I can actually look up here to understand? Without knowing where this log file is, without even having access to that machine's running somewhere in our AWS account. I don't neither know which machine specifically it is, nor would I ever get a login for that machine. As an operator, I can still do my job effectively by saying, first of all, yes, the problem corrected itself automatically, so good thing, we have obviously somebody that is looking after this process, but yes, it took 5 minutes between the process being restarted, and if it crashes once every night, maybe it is a problem that we should start looking into and shouldn't just result ourselves to say, you know what, it's just 30 minutes, it solved itself, so don't worry about it. So that in a nutshell is the value proposition of Dynatrace as a monitoring solution. Deploy an agent that will automatically learn about your environment, learn about processes, the infrastructure, learn what's normal, what's abnormal, build up a model, and then leverage this model to give you in one short sentence, answers instead of more data. That's fundamentally what Dynatrace was built to do. And if you want to either try it out on your own environments or want to get a more detailed demo, obviously I can only scratch the surface in the couple of minutes I have, please reach out to our local partner, HT Solutions. They can help you with trying it in your own environments, and I'm sure that you'll see this is not just something that works in demo platforms, because I always jokingly say every product looks good in a demo. Of course, we have full control over what we do here. The same product also works in real-life scenarios. Thanks for listening, and I hope at least some of you might find this interesting and useful. Thanks.